Hello, welcome to everyone. In this video, this is our lecture number 3. Already two lectures are covered. In the first lecture, we actually learned about the singularity point, which is regular or irregular. We will discuss in detail, that is the how we can find out the ordinary point or regular singular or irregular singular point of a second order linear differential equation. So in the next class, we will discuss about the Frobenius method in details, how to solve any second order linear differential equation using Frobenius method. So if you want to watch the previous lecture, you can go through the description box, link are given there. In the last class, in the lecture number 2, we actually give you a homework. In this homework, we will give this equation, that is x square d2y dx square minus 6y equals to 0, and another one was the x dy dx minus 6y equals to 0. These two homework actually given, and additionally there are also two. And we say that, and the next class we will be discuss about the solution of this equation. So let's start with the solution of this equation. Actually, this is the special equation which has the different in the common example. Okay, so that's why we discuss this example in detail. So let's start. You can watch this. This is the syllabus of this University of Calcutta mathematical methods, and we discuss in the first lecture this one, and the second lecture this one, and in the third lecture we actually discuss the special case of the Frobenius method, special example. Actually, you can say these are the all the syllabus of these mathematical methods of this equation. Okay, right? So let's start with this equation which says that the x square d2y sorry, x square d2y dx square minus 6y equals to 0. In general, we take the in the Frobenius method, that is y is a summation ak x to the power m plus k, where k stands from 0 to infinity, a0 not equals to 0. Take this derivative with respect to x and the second derivative with respect to x. Now if you put in this equation, you will be get this expression. Okay, so in general, we compare the lowest power of x, which is x to the power m. If you put k equal to 0 in this expression, you will be get x to the power m. So this one is here, and from here you will be get this one. You know a0 not equals to 0, so that's why m equals to 3 or m equals to minus 2. Now if you compare the coefficient of x to the power m plus 1, then you will be get this expression like that. Just put this x equal to k equals to 1 in this expression. You can easily find out this expression, and then rearranging them, you will be get this value a1 equals to 0, or m equals to minus 3, or m equals to 2. Now if you compare the x to the power m plus k, you will be get this equation. So you can see here there is no recurrence relation actually found. In the others example, we can easily find out the recurrence relation, and obtaining the m value, we can easily find out from a0 to a1 a2 a3, or a0 to a2 a4 a6, and a1 to a3 a5 a7, and so on. But here there is no recurrence relation. That means this coefficient actually is 0, except the a0 equals to not a0 not equals to 0, right? So other coefficient must be 0, only a0 not equals to 0. So if a0 not equals to 0 and m equals to 3, in the first case, m equals to 3, when m equals to 3, you can easily say that a1 equals to 0, and there is no problem, because in the other coefficient must be 0 except a0. Except a0, all coefficient must be 0. You can write here, ak equals to 0, k not equals to 0, k actually 1 to infinity. For that case, ak equals to 0. You can easily write down this one. So only a0 is not equals to 0 and that case. Okay, so if you put this expression into this, you will be get m equals to 3. So this one is the one solution. And when take m equals to minus 2, you will be get this expression. So this is the another solution, and you know the linear combination of these two solution actually the total solution. So the total solution will be like that. I think clear about the solution of this special example. Actually in this example, you will be arises at that point, that is the no recurrence relation actually found. This is the problem, and we can conclude that all the coefficient actually 0, only a0 not equals to 0, because when we take the Frobenius method, the first term must be not equals to 0. That's why a0 is not equals to 0, and the solution becomes like that. I think clear. If there is any doubt, you must comment in the comment box. Go to the next example we actually given in the last class as a homework. You can see the same things like that. You will take the first derivative and put this example. You can get the same power. If you take the coefficient of x to the power m, you will be get m equals to 6, and if you compare the x to the power m plus 1, you will be get m equals to 5 or a1 equals to 0. When take m equals to 6, you can easily take the a1 equals to 0. Actually the all coefficient actually 0 except k equals to 0. Ak equals to 0 where k equals to 1 to infinity. A0 not equals to 0. So A0 not equals to 0 means only this term exists. So the solution will be like that. I think clear about all these things. If there is any doubt, you must comment in the comment. These two are the your homework. You must do this. I think you can now do this solution very easily. You can do this solution very easily. These are the same as we discussed in this class. Okay. So in the next class, we will be discuss the special differential equation like legendary, Hermite and Bessels. We already discussed in the first class, that is these are the special equation differential equation whose solution must be remembered for the further uses like nuclear physics, hydrogen molecule solution, etc., etc. So in the next class we will be discuss about the legendary differential equation, legendary polynomial, etc. Okay, so that's it for today. This is all about me, and this is my contact details. You can connect with me with this telegram channel, and these are the my online platform, and this is my youtube channel details. Go to this channel, you will get the different physics related video like this session. If you learn some things from this video, share this video to your friends so that he or she also get benefit from this video. Subscribe this channel if you new in this channel. Those already subscribed, thanks for subscription. Press the bell icon to get the notification of upcoming video. So take care, we'll meet in the next video as soon as possible.